All right, Algebra 2, welcome back, guys, to another amazing note video. Section 6. All right, we're talking about radical expressions and rational exponents. This is all about using the square root, the cube root, even the fourth root, and then using exponents that are actually fractions. And that tells you a couple different things. Okay, so you have fractional exponents that if you wanted, you could convert those back into being radicals. Whenever I say radicals, I'm talking about square root, cube root, fourth root. And you're going to see all that stuff in this section. Technically, this is review. This does go back to Algebra 1, but I will admit, I know it's been a little while. So pay close attention to all the example problems. Everything you see highlighted, you must copy down into your notes. It's going to be helpful to have for both homework as well as test. And anything that is highlighted, the expectation there is that not only are you copying it down, but you understand it. And if you don't understand it, then you're asking questions about it. And so that's going to be something that you need to capitalize on in class. If you highlight it, or if I highlight it and you copy it down, then you need to understand it. All right, so everything you see on this page right here, highlighted, got to take care of that. Okay, everything you see right here. Okay, so if you're looking at this page right here, we have rational exponents. Okay, and so a rational exponent, basically, you know what an exponent is, and rational just in terms that it is, in fact, a real number, and rational in terms of it's not equal to 0. Because if the exponent were 0, then the overall solution to it would just be 1. You guys remember that? Anything to the 0 power is 1. Okay, but the key thing you have to pay close attention, let's zoom in on it, is the conversion between an exponent that is a fraction. So I'm talking about this right here. And then what that looks like if you convert it to be a radical. Okay, so the number you always start with is the denominator of the fractional exponent. All right, so what I mean by that is we are going to focus by looking at that 4, because that bottom number tells you what radical you are using. That's a 4, so that means we are taking the fourth root right here. So in other words, a fourth root. Then you take a look at the numerator, the top number, and that is what you would use as a final exponent in your answer. So 2 to the power of 1 still is 2. But let's take a look at this example here. There's a 3, so that means it's going to be a cube root or a third root. That's what you're seeing right here. And the cube root of 8 is 2. Then this number, the numerator, is the exponent that we're going to take that answer to. So this 2 is this 2 is this 2, and then 2 squared is how we're getting a final answer of 4. Okay, it's important that you know how to go both directions here, whether they give you a radical to start with or they give you a fractional exponent to start with, and then you're going to have to convert that. Okay? All right, and then right here, they're just giving you all the basic properties, okay? So when you're dealing with the same base and you're multiplying, you add these exponents, and that's what they're showing you right here. And then after you add these exponents, you get your final exponent, and then you actually solve that to get that solution there. Okay, if you have the same base, also this works with variables. Okay, so the base number right here is the same. You're using division, then you would subtract these exponents. That's what you should see right here. Get that final exponent and actually figure that out. 125 to the 1/3 is the same thing as saying 125 cube root. So cube root of 125 is how they're getting 5. Okay, and you remember cube root, that's that guy right there. Okay, you keep looking. This right here in parentheses means everything in here is brought to this exponent. So that's essentially them distributing this exponent to both parts in the parentheses. That's how they get this piece here. And then anything to the 1/2 power, that's the same thing as saying the square root. So the square root of 16 is 4. The square root of 25 is 5. And then multiply these to get the 20. All right. And then same thing applies. If you have division, same rule. Take that exponent, put it with both parts of the fraction, take whatever that fractional exponent is, and apply it to those numbers. All right, let's go into some example problems here. All right, we want to have the 4th root of negative 256. There should be a red flag going off, and if it's not, that's fine, but listen closely then. 4th root, that's an even number. Okay, 4 even number. And if you went back up into your notes, and you should have written everything down that was highlighted, even number roots can only be taken of positives, and this is a negative number. So because that is an even number root, you can't take it with a negative number. So this is a no solution problem, because you can't take an even number root of a negative number. It will always only equal a positive. All right, let's move on to this one. Find all roots, and what we're doing is a cube root of 125. Another way to think of this, let's rewrite this. Cube root of 125 equals x times x times x. We're trying to figure out what number multiplied by itself 3 times is going to equal 125. I always recommend when you're doing cube roots or 4th root situations, start really, really low with your educated guesses. Okay. And a key thing to notice here, for starters, it ends with a 5. So you know that this number in your answer is going to have a 5. That, to me, is the easiest way to have your guess and check options. So I'm going to try the number 5. And when you work that out, it is 5. All right. So that's what we're looking at here. The cube root of 125 is 5. What does that mean? 5 times 5 times 5 is 125. All right. So now let's figure this one out. We have a 4th root of 16x to the power of 4. So if you want to, you could break this up into 2 separate problems. The 4th root of 16 and the 4th root of x to the power of 4. Here's what you do when you have a variable with an exponent and you're taking some type of root. If this number and this number are perfectly divisible, divide them. And that's exactly what we're going to do here. So 4 divided by 4 is 1. So this just equals x. All right, it'd be x to the power of 1. Now, this right here, what you're trying to figure out is what number multiplied by itself 4 times is going to equal 16. All right? And in this case, it's going to be 2. Like I told you, always start with very low numbers. So what this means is 2 times 2 times 2 times 2 is 16. So there's 4 2's. Don't say 2 times 4. That's 8. That's not what we're doing. Okay? So just to double check that you understand this, this is saying 2 times 2 times 2 times 2. That's how I get the answer to be the number 2. So all of this right here, it just equals 2x. Okay? All right, just 2x. Okay, so example problem number 4, we're taking the 4th root of x to the power of 8 over the number 3. And what we're going to do is we're going to rewrite this so you could see what you're really dealing with. And it's completely all right to rewrite this so that it looks like this. All right, and here's why. because x to the power of 8 works out perfectly. You guys remember in the last problem, we did 4 divided by 4. That's how we got x. So we're going to do the same thing here. We're going to do 8 divided by 4. And that is going to give us a very nice just x squared, because 8 divided by 4 is 2. However, this fourth root of 3 does not work out perfectly. It doesn't work out nicely at all. So how do you get rid of any roots in the denominator? We'll take a timeout. Never leave a root in the denominator. That's what we're getting at here. So you can't leave a square root, a cube root, or a fourth root, any of those in the denominator. So how do we get rid of those? Here's what we're going to do. We're going to multiply by it. We're going to multiply the top and bottom by the fourth root of 3, because the rule states if you have the same exact number or variable under either it's a square root, cube root, or fourth root, they're both fourth roots, and this is both 3, it will equal itself. So this means that we're going to rewrite our answer down here. You're going to have x squared fourth root of 3 over 3. This part right here, the x squared fourth root of 3, can't be combined, so just show them being multiplied next to each other and leave your answer just like that. Okay, the 3 in the denominator works. There's no more square root, radical, or anything in the denominator, so everything has been simplified there. Okay, next one. Here's what we have to notice here is that they are both cube roots. If they are both cube roots, you could then put them together. You've seen me do example problems in this section here where I took one cube root and expanded it out, or one fourth root and expanded it out. The same thing applies. You could show them together. Here's why we're going to do that. Because x, they're both the same base. Both the same base being multiplied means I add the exponents. So this is going to be rewritten as the cube root of x to the power of 9. This is why 9 does divide perfectly by 3. That's why you're showing them being put together, because you would take 9, divide it by 3, and that's going to equal x to the power of 3. Perfect. That one's done. All right. Move on to number 6. Simplify. All right, this is a fractional exponent. You always start with the denominator number. If it's a 2, that means square root. If this were a 3, it'd mean cube root. If this were a 4, it'd mean fourth root. So we're going to rewrite this. It's a 2, so that means square root of 4. Put it in parentheses, and then take that answer to the 5th power. So order of operations, do what's in the parentheses first, then use the exponent. This is going to be 2 to the power of 5. All right. And 2 to the power of 5 simply equals 32. All right, so again, always start with the bottom number. This is what tells you what root to use. After you take that root, this top number tells you what exponent to use. All right, now we're going to rewrite this using exponents. Okay, so going backwards, the number right here, if there is one, is what's in your denominator of that fractional exponent. The number right here, if there is one, is the top part, the numerator of that fractional exponent. So this is going to be 5 to the 2 over 4, but don't leave it. Why do you not leave it? Because 2 over 4 can be reduced. So you're going to actually reduce it to 5 to the 1/2 power. All right, remember, this is your denominator, this is your numerator, and if you can reduce, reduce. All right, let's simplify here. Same base. Both have 36. Same base. Being multiplied means we will add these exponents. So this is the same thing as saying 36 3/8 plus 1/8 is 36 to the 4/8. Remember in the last problem, what did I say about being able to reduce fractional exponents? If you can reduce a fractional exponent, reduce it. So this is now 36 to the 1/2. This is now actually saying square root of 36, which equals 6. So all of that right there, what I did was I used some simple multiplying with exponents. That's what we started with. Add your exponents. Then you have a fractional exponent. You got to reduce it. Once it's reduced, simplify further if possible. Anything to the 1/2 is the same thing as square root, and it does work out perfectly with that square root. All right. Now, same base, same number, same variable, same base. All right. Division means you will subtract your exponents. So this is rewritten. Same base, it's 5. Then 9/4 minus 1/4. You use subtraction when the original had division, but they have to have the same base for this property to work. All right, simplify that. 5 to the power of 8/4. I can simplify this fractional exponent. 8/4 can be reduced to 5 to the second, and that in itself is 25. All right, follow that whole progression, that whole procedure there. All right, and last question, what's your favorite office quote? All right, I'm gonna have to think about it. There's a lot of good ones out there. Tell me the next day after you watch this, what's your favorite office quote? All right. Let's zoom out. Everything, example problems right there, 7 through 10. All example problems right there, 1 through 6. All right. Pay close attention, ask questions. I'll see you guys in the next video.